This course serves as a brief introduction to artificial intelligence, or AI, and how we can use some Microsoft Azure services for fulfilling our AI requirements. The topics that will be covered today map directly to the AI 900 Azure AI Fundamentals examination. It is ideal if you have a basic understanding about Azure and the cloud in general. Since today's content will be predominantly about AI, if you're completely new to the cloud, I would recommend that you attend the AZ 900 Azure Fundamentals course to fill up some gaps in your learning. The Azure Fundamentals course covers more generally the cloud concepts, services available on the cloud, and the advantages of working on the cloud. Before we begin, let me share a little bit about myself. My name is Rama, and I am a Microsoft technical trainer from Singapore. I'm a former automation engineer who transitioned into teaching Azure. And I love my job because of the amazing people I get to interact with and learn from every single day. I enjoy playing football, listening to music, and climbing mountains. So if you're ready, my job today is to help you conquer your own peaks by helping you prepare for the AI 900 certification. Please note that this course is supported by materials on Microsoft Learn. You can refer to aka.ms/azurelearn_AI fundamentals. The content there serves as a revision for the examination, closely mirroring what I will be covering in today's session. And on the slide, you can see the content that we will be covering for this course over 4 modules. In Module 1, we'll start with an introduction to AI, where we will discuss basic AI concepts, AI workloads, and principles of responsible AI, followed by a brief introduction to AI services in Microsoft Azure. In Module 2, we'll discuss machine learning. What are some applications of machine learning, different types of machine learning algorithms, without getting too deep into the weeds about the math. And we'll briefly touch on the concepts of regression, classification, and clustering. Nothing too complicated. We'll also look at how some of these can be implemented on the cloud using the Azure portal and the Azure Machine Learning Studio. In Module 3, we'll get into a major application of AI, which is computer vision. We'll get an insight into how computers interpret the world visually and the services on the cloud that we can use to fulfill our workloads. And finally, in Module 4, we will learn about natural language processing, also referred to as NLP. NLP is how computers interpret written or spoken text, and we will see some applications of NLP such as conversational AI and bots that make use of conversational AI to interact with customers. The goal for this fundamental course is for you to be able to identify and describe AI concepts and their related Microsoft Azure services. By the end of these 4 modules, I want to give you a broad understanding of AI workloads, along with the tools and technologies to help you accomplish them on Azure. We'll be going through some demos throughout this class, and you can find the instructions for this lab at the GitHub repo associated with this course at aka.ms/AI900labs. Let's move on to Module 1, shall we? In Module 1, we'll be presenting this over 2 lessons, starting with a brief intro to the concept of AI. And then we will move on to discuss AI in the cloud, and more specifically, Microsoft Azure. In the first lesson, we'll have a brief introduction to AI, and I'll be sharing the definition of AI, some common workloads that we can carry out using AI, and finally, a very important topic. We will discuss the principles of using AI in a responsible manner, the challenges and risks involved when deploying AI. With the increasing role of technology in our lives, practicing AI responsibly has become crucial. What is artificial intelligence? Artificial intelligence is the science and engineering of making computers behave in ways that we, until recently, thought required human intelligence. So imagine AI to be no different from a baby. So when a baby is born, she starts to make sense of the world through her senses and absorbs any information that is provided to her by her parents. They point at an animal with 4 legs and they teach her that it's a dog. And she might initially think that everything with four legs is a dog. An elephant, a cow, a giraffe, maybe even a chair. And then we provide her with more information to supplement what she already knows, to help her distinguish between all things with four legs. And she learns to tell the difference across all of these four-legged creatures and items. AI is a bit like that. This is the process that we are trying to emulate for computers, so that computers can start to carry out some laborious, repetitive tasks on our behalf. There are several human capabilities that AI can imitate. Let's look through some of them. Humans are very good at making predictions or recognizing patterns using available information and experience. On days that it rains, we might notice that the air conditioning inside the building is a little colder, so we might raise the temperature in response. So provided with that same data and past outcomes, computers can learn how to make these predictions by recognizing those same patterns. We'll talk more about this in later modules. Humans are also very good at intuitively knowing when something isn't quite right or doesn't fit an expected pattern. Perhaps when your usually noisy kids are being surprisingly quiet and well-behaved, you might want to start looking around the house to see if something's broken. Software can also take over this job from us because they are very good at spotting anomaly. And we can build in automation to start workflows based on such anomalies. Humans use sight to experience the world visually, and we can recognize people and landmarks in a photo. Instead of eyes, computers have cameras that allow them to receive this input, and they can analyze images and videos. We can also communicate by writing and speaking and engaging in dynamic conversations, having to respond appropriately. Software can now do this quite well. We see chatbots interacting to answer common queries, engaging in dynamic conversation to provide you with the relevant information based on your query, and playing the right songs based on your request. Finally, we are also very good at extracting information from multiple sources to extend our knowledge. We can see an image of Mount Everest and connect it to documentaries or movies or facts about Mount Everest that we've come across. AI can also make these connections across multiple databases and sources to connect this information that used to be stored separately and queried separately. Now they can be queried at the same time. However, since your time and mine is better spent on more value-adding activities rather than things that are dull, difficult, and repetitive, it is a good idea to outsource these tasks to our machines using AI software. Imagine a future where you can do your online shopping or catch up on some reading while your self-driving car brings you to your location. This table below shows the human traits that I just described and how they can be carried out by software. For the rest of this course, we will be going in depth into each of these types of workloads. And a lot of AI work is about providing data models with good quality data to be able to train these computer software and build deployable models that can then spot those patterns in unseen new data to make predictions. So let's first start with machine learning, where our aim is to create predictive models based on data and statistics. It is the foundation of artificial intelligence. A possible application of this could be to build a model to predict housing patterns. If I was selling real estate, from experience, I know that apartments on higher floors tend to fetch a higher price. But if I wanted to know exactly how much more a house on the 9th floor costs as compared to one on the 8th floor, I can train a machine learning model based on past transactional data. A fairly simple model that can be made more sophisticated based on the quality of the data available. We will see one such example in Module 2 a little later. Next, anomaly detection. It's about detecting unusual patterns and behaviors. And it should be noted that this is about detecting something that is very rare in the data. A good example to think about is credit card fraud. Let's say I purchase something at a grocery store near my home in Singapore, and 2 minutes later, another transaction is attempted at a shop in Canada. That is something that is very strange compared to my usual credit card behavior. So the algorithm is probably going to say something like, uh-oh, something's going on, and flag this anomalous behavior and block the suspicious transaction, and maybe my card. Sometimes this can backfire. It might be a scenario where you're simply on vacation and using the card on the other side of the world, and the algorithm ends up flagging your legitimate activity as suspicious. Algorithms are, of course, not perfect, but they get better as we train them with higher quality data and more data. Computer vision has some common applications that we probably have already seen in the papers or heard in the news. Things like facial recognition, object and distance detection on self-driving cars. It can also be used in manufacturing lines for sorting, quality control, and workplace safety. Natural language processing, or NLP, that's one of my favorite applications. And it has so much potential. We are already experiencing the benefits of NLP on a daily basis without even realizing it. Spelling and grammar checks on your text editors, spam filters in your email, voice assistants on your smart speakers, phones and watches. As you provide more and more input, be it verbal or textual, the machine uses NLP to respond accordingly. And finally, knowledge mining is an emerging discipline in AI that allows organizations to deeply understand and explore their information stored across several databases and uncover hidden insights to find relationships and patterns at scale. This is something that has massive potential for application in marketing. And these are 5 distinctive AI workloads. And while building out a solution, you might have a combination of these workloads. For example, imagine a conversational AI solution that uses a bot to process an auto insurance claim. The bot relies on some natural language processing capabilities to make sense of input, such as, I want to submit a claim. It may allow users to send a photograph of a damaged vehicle, and using computer vision, it would assess that damage and apply a machine learning model to predict likely repair costs. And the bot might also use anomaly detection to identify potentially fraudulent claims. Finally, the claims data, including forms, photographs, and other artifacts, might be indexed to extract insights and create a searchable knowledge store to help manage future claims. At Microsoft, when we develop AI software, we are guided by a set of 6 principles. Everything that we are discussing with regards to Microsoft Azure will have these principles baked into their software and operations. Since we're using AI to tackle some of the biggest challenges known to humankind, we need to be responsible since there are challenges and risks that come with AI. Also, these will come up in your examination, and I will make sure to understand the differences across them really well. First, fairness. AI systems should treat everyone equally. Suppose you have a loan approval algorithm for a bank. The model should make predictions of whether the loan should be approved without incorporating any bias based on gender, ethnicity, or any other factor, right? Because it might disadvantage a specific group, and that's not fair. However, if a loan approval model discriminates by gender due to bias in the data using which it was trained, in the past, maybe there had been an implicit bias in the way that human loan officers gave out these loans. If we feed this wrong data of accepted and rejected applications based on past results to train the model is also going to behave the same way as these biased loan officers and continue to propagate those biases. And we want to avoid this because everyone is equal and we do not want to continue making the same mistakes from our past. So models need to be rectified to eradicate such biases so that we do not disadvantage any groups. You can tackle such biases on Azure Machine Learning since it includes the capability to interpret models and quantify the influence each feature has on the prediction model. That way you can analyze each feature, its level of influence on the outcome, and determine if there is any cause for concern and tackle those biases. Second, AI systems should be reliable and safe. Otherwise, they should not be encountering human beings and putting them at risk. We have been hearing all this news about amazing autonomous vehicles that can park themselves, stop at red lights, obey speed limits. But let's take a situation where an autonomous vehicle is fed some bad data or encounters a system failure. Or perhaps it is unreliable in making decisions when the camera does not have sufficiently clear photos. Should this car still be allowed to be driving on our roads alongside humans? We might be causing substantial risk to everyone on the roads. That's why AI-based software development must be subjected to rigorous testing to ensure that it works as expected before it gets released. Next, we must ensure that AI systems are secure and respect privacy. This is because some of the large volumes of sometimes sensitive data that AI-based software has access to and are trained with could be highly sensitive, and there could be personal details that must be protected. Since we are using hard data to train these models, it is also possible for hackers to gain full access to the original data. Let's say a medical diagnostic bot is trained using sensitive patient data and their diagnostic scans, and the data perhaps is not stored securely or encrypted. If hackers get their hands on the data, it could be very damaging and prone to abuse. And that is why there is so much focus on anonymization and data privacy and multiple levels of security for such sensitive data. Fourth, it is important for us to keep inclusiveness at the forefront. There are many solutions that improve the lives of many people, and it is easy to sometimes overlook circumstances where not everyone is able to benefit from that solution. AI systems should always empower, engage, and benefit everyone in our society, regardless of education, orientation, gender, socioeconomic status, or physical ability. And nobody should be systematically left out of being able to enjoy these benefits. Let's take the example of perhaps a predictive keyboard application that I use on my phone on a daily basis. I cannot imagine being without it right now. It has allowed me to spell complicated words by pure guesswork. But that application does not have audio output, so visually impaired users may not be able to access it. Next, AI-based software should be as transparent and understandable as possible. Users should be kept informed of how their data is being used, the purpose of the system, how the application is generating the guidance and advice, and be open with customers about the limitations and expectations. This way, customers can make an informed decision about whether to participate. Imagine we have an AI-based financial tool that gives you investment advice. Should we just follow it blindly because someone put the AI tag on it? The tool might be controlled by some bad actors who are manipulating large groups of investors to take their money. So we should be very careful. And finally, designers and developers should work within the frameworks of organizational principles and governance to ensure that their solutions meet clearly defined ethical and legal standards. If you've worked with code before, sometimes you don't know why your code works, but it works. And we don't want to change anything. I was the same way in school. But we cannot take the same approach with AI because the stakes sometimes can be much higher. And we need to know exactly why something works in a certain way. Someone has to be accountable for that solution. When nobody is accountable for these AI-driven decisions, things can go south really quickly. Imagine an AI-driven court judgment putting an innocent behind bars. If we have offloaded that decision to an AI system and not considered all the facts, because no two decisions are the same, there's no way to feed all of the parameters involved in a case to an AI system. So who is responsible to say if the AI model identified the person accurately? In Lesson 2, I will be discussing how we can start to work with AI on the cloud, specifically Microsoft Azure, and introduce some of the tools available for you to get started building out your own AI solutions on Microsoft Azure. There are several reasons why working on the cloud can be beneficial, especially when it comes to using AI workloads. The main advantages of working on Microsoft Azure are scalability and reliability. What do I mean? The cloud offers almost an unlimited amount of data storage, whereas your own laptop or PC might just have a few terabytes of storage at best. Having a large space to host your data allows you the convenience of storing and using the valuable data that is vital for your AI application. And then we have compute, another key component for AI. Training a simple model might just take a couple of seconds. But as algorithms get more complicated, perhaps we're training an object detection or a facial recognition model, and the amount of data that we have to feed these AI training models increases. And this training might require an immense amount of processing power and time. Sometimes this can be in the scale of hours or even days if you're working with videos and using a normal laptop for training. However, we can cut this processing time down to several minutes on the cloud by deploying powerful compute resources on the cloud. Finally, there are some cutting-edge services available on the cloud for consumers to start developing their own solutions with minimal setup time and cost. So users do not have to spend much time worrying about the environments. They can simply deploy services on the Azure portal and get started developing their AI solutions right away. With that, let me now bring your attention to the diagram on the right. Let me start with the smallest unit in the diagram, resources. Throughout this course, we might sometimes use the word service and resource interchangeably, but both refer to the over 200 services that you can deploy and use on Microsoft Azure to build out your solution, which includes virtual machines, databases, AI services, many more. These resources need to be organized under resource groups, which can be thought of as organizational buckets. You can sort your resources into resource groups any way that you like, by resource type, the application that they're a part of, the department that created them. That's entirely your choice. But a resource group is compulsory before you can create any resource. And what's useful about a resource group is that there is a parent-child inheritance relationship between them. So I can use this relationship to govern or to control permissions on these resources. And also, once I delete a certain resource group, it automatically also deletes all of the resources inside. Finally, most important is that before you can get started creating or using any resources on Azure, you need to have an Azure subscriptions. In fact, you need to have an Azure subscription to do anything on Azure. A subscription is a billing and access boundary which lets you organize and manage your costs on Azure. So let me give you a brief tour of the Azure portal so that you have a better idea. Welcome to your first look at the Azure portal. So right at the top, you can see that we have a couple of services. Let me just walk you through some of them. These are the last few services that I've used. So anytime you are moving across different services, these will keep changing. And slightly lower down, you have recent resources that I've created. I've created some resources a few weeks ago, a few months ago. And then slightly lower down, you have some other quick resources that you'll be able to access. Things like your subscription, your resource groups, and then tools like Microsoft Learn, your Azure Monitor, which helps you to monitor the usage of your applications, your Microsoft Defender, which is like your antivirus or your protection for your environment. So what I want to bring your attention to is the ways in which you can navigate your way around Azure. So one of the ways that you can do that is using the hamburger menu at the top left. If you open this menu, you can see all of your favorites. And the advantage of having the favorites is that you can always reach them really, really quickly. And you can move them around. You can rearrange them as you feel, as you wish. So if you always use a lot of storage accounts, you can keep it higher up. If you use virtual machines a lot, you can also move it closer to the top. And if you clicked on all services, you'll be able to view all the Microsoft services that you can deploy. And these are the categories of services that are available on the cloud. So things like compute, things like mobile, storage, all of these are Microsoft-specific resources. And anytime you're lost on the portal, you can always click on the word Microsoft Azure and you'll be brought back to the home. And my favorite way of navigating Azure is using the search bar here. If I was going to look for something like, let's say, virtual machine, I'll type the word virtual, and you see anything with the word virtual, be it services by Microsoft, services in the marketplace, these are third-party applications, any of my resources with the word virtual in it, and most importantly, the documentation with the word virtual. So if you are interested in finding out what is, for example, virtual networks in Azure, you could click on this and it'll bring you to the documentation about virtual networks and virtual machines. So the search menu, search bar is a very powerful way to navigate around Azure. Additionally, to the right of the search bar, you also have the option to open up PowerShell. PowerShell is a very powerful feature of Azure. Instead of using the graphical way to deploy resources, you could do it in a command line with a command line experience. And right next to that, you have your directories and your subscriptions, and you have various alerts and notifications that you can get from Azure. So when resources are being deployed, the notifications will let you know when they're completed deploying. And then you have additional settings. If you want to change your language, your currency, all of that, those settings are up here. And then you can also interact with Azure, with Microsoft to get any support or any troubleshooting done. And finally, you can also give some feedback. If you think there's something that could be done better or some things that are done well, you can provide feedback to Microsoft. And that won't be the last time that you'll be seeing the Azure portal. I will be carrying out several demos inside the Azure portal in the rest of today's session. Let's get back to the course material, shall we? And today we shall also be exploring the following Azure AI services. First, the Azure Machine Learning. Azure Machine Learning is designed for developers to train, test, deploy, and manage machine learning models from scratch, meaning they can experiment with data to make predictions. They can work starting from a data set and manipulate it to generate insight and predictions from that data with full autonomy on what type of model to use, how to make the predictions. And you're usually going to find data scientists and data analysts playing around with this tool. A major advantage of this tool is that you don't have to worry about spending any time setting up the environment. The moment you deploy the service, you can immediately start hacking and building out your solutions using the tools inside of the Azure Machine Learning environment. Second, we have cognitive services, which is a collection of services that can be categorized into 4 main pillars. These are vision, speech, language, and decision. These services enable your application, website, or bot to see, hear, speak, understand, and make decisions by building intelligent capabilities into what you're developing. You can add different types of cognitive features without requiring any development skills or data science capabilities, because Azure helps you with that by providing pre-built products that you can immediately use and deploy to help your products to see, hear, and speak. Third, we have the Azure Bot Service. The Azure Bot Service is focused on developing, deploying, and managing your intelligent bots in a single location. We've all probably had the chance to interact with chatbots on some websites. Spoiler alert, quite often it's not an actual human sitting and replying to your every request. It might be a smart robot customer agent that's generating replies based on historical conversational data and insight that it is drawing from interacting with you. A fun fact to know is that bots also have a feature that enables chit-chat, which gives them some personality and lets you exchange niceties like a human. They can respond to you when you greet them, for example, when you say good morning, or you can respond with things like, I'm glad I could help, when you say thank you. Finally, we have Azure Cognitive Search, which provides you with a rich search experience. Cognitive Search is a platform as a service, cloud search capability that lets you create search-enabled web, mobile, and enterprise applications. It connects to different types of data sources, understands them, whether they are structured, unstructured, and makes them searchable. And that's a brief intro to the types of artificial intelligence products that are a part of Microsoft Azure's product offerings that we will be discussing for the rest of today's session. Don't worry if some of what I shared on this session was a little alien to you. We're going to go through them together in greater detail for the rest of the session. So stick with me. I would like to spend a little bit of time talking about cognitive services. Azure provides a set of cognitive services that encapsulate common AI workloads. Deploying cognitive services is probably the quickest way for anyone to add vision, speech, language, or decision capabilities to their solution, as they can take advantage of the platform that has been developed by Microsoft. These off-the-shelf cognitive services can help you develop a solution more quickly and with less specialist expertise. What I really want to highlight is that there are two ways for you to deploy cognitive services. You can either deploy it as a standalone resource specific to the service that you want to deploy, namely vision, speech, language, or decision. Perhaps you only want to create a resource to do language translation and nothing else. Then you could deploy that specific standalone purpose. Or you could also deploy a general cognitive services resource, which encapsulates multiple services. And you could use that same service to carry out computer vision workloads, speech workloads, language workloads, decision-making workloads. But why would you do that? There is no right or wrong method of consuming these services or building out the solution. Using a standalone service-specific resource enables you to manage costs and access to that service independently of the other services you may be using, while a general cognitive services resource enables you to combine all of your AI resources in a single Azure resource for centralized management. So regardless of the type of service you use, standalone or general, client applications will consume the services by connecting to a REST endpoint, which is a HTTPS address to which they can submit requests using a resource-specific key for authentication. A REST API is a way to interact with a computer or a system to retrieve information or perform a function. An API helps you to communicate what you want to that system so that it can understand and fulfill your request. So in a computer vision application, you might send an API request with a photo and request the service to identify all of the faces within that photo. The cognitive service receives your request, understands what you require, and carries out the tasks and returns that photo to you with the identities of all of those faces that it located on that photo. So let me take you into the Azure portal to see how we can use some of the AI capabilities on Azure. For the first demo today, I'm going to be creating an anomaly detector resource. An anomaly detector resource, as the name suggests, spots anomalies in any behavior. So we'll see what kind of behavior will be spotted in this example. And as I said, there are several ways to navigate around Azure, and I'm going to search for anomaly detector using the search menu right here, the search bar at the top. And anytime you go into a resource, a category, at the top left here is how you'll be able to create this resource. So when you click on this plus to create, you'll be brought through a wizard. And this wizard will guide you step by step through how to create this resource. So for first things you need to have is a subscription. Without a subscription, you won't be able to do anything inside of Azure. And since we are creating a resource, you need to have a resource group. This resource group is like a bucket that holds multiple resources and it can help you to govern this resource. So I don't have any resource groups at this point. I'm going to create a new resource group. I'm going to call this AI 900 Virtual Training. And this tick indicates that this name is a valid name. Click OK. I'm going to keep going. And I'm going to create this instance in the East US. It doesn't matter really where you create it. The performance is going to be quite the same. But usually you want to choose something that is closer to home for you. Let's say East US Anomaly Detector AI 900 Demo. And this is a valid name. So I got a check mark here. And I can go ahead and deploy this resource. So for pricing tier, I'm going to choose a free resource, since I'm not going to do too many transactions on this. And I'm going to go ahead and review and create this resource. So when I review and create this resource, it's going to check if all of the details I've indicated are valid, and I'm allowed to create this resource based on my subscription and my and the location I've chosen. So it reviews everything and it says validation passed. Now I can create this resource. So I'm going to go ahead and do that. So now our resource has been created and we are ready to use this resource. So for that, I'm going to first go to resource. And at the overview, you can see the overall details about this anomaly detector, which resource group it is in, its current status, it's active, the location it's been created in, the subscription it sits inside, and the tier, the API type, all of that stuff is available for you to view in the overview. And then before I can use it, I need to be able to consume this resource. And you're going to be able to do that using the keys and endpoint. So these are the secret keys and the endpoint, which sort of serve like your password to be able to use this resource. Because if you had a paid resource, using this password does cost money. So that's why these keys are kept hidden, and you should not reveal these keys to anyone. For this demo, this is a free resource, so it's not really a problem because there is a limit on how much you can use. And how am I going to consume this resource? I'm going to be using the Cloud Shell. The Cloud Shell, as I mentioned a little earlier, is up here. And open this. And it's going to take a while to request the Cloud Shell and obtain storage accounts and compute capabilities for me. So let's wait. I think we're ready to go. So we open PowerShell and we are going to download a couple of files from GitHub for that. For that, I'm going to copy the instructions from the lab. And I'm going to be cloning this repository into this folder, AI900 virtual training. Oh, it's got to be together, virtual training. And this is going to take a quick while to clone this repository and allow me to use it. So now if the files are already loaded, now I can go and take a look at and modify these files. So inside of PowerShell, I'm going to be able to view this. This is where the files are inside AI900 virtual training. This is a folder inside my storage. So I'm going to go and find the resource that we're going to use is detect anomalies. And detect anomalies, what we need to do is we need to obtain the keys and endpoint from our Azure Portals resource. So the resource up here, the key needs to be replacing this text over there. So let's try and do that now. I'm going to copy this and I'm going to replace this text. And I'm also going to copy the endpoint and bring it over here. And I think we're ready to go. We're going to go back to our command line and try and obtain this, try and consume this resource. So what I'm going to do is going to navigate into this folder, cd change directory AI900 virtual training. Now we're inside that folder. What we have to do is we have to run this script /detect anomalies. So this is the script which we populated with the key and endpoint. So the moment I hit enter, what we're going to see is that this is going to process a file that contains a series of dates and times and numeric values. Why is that important? So you can imagine this being a pressure cylinder where temperature is important, because if the temperature goes too high, the pressure goes too high and we could risk damage, for example. So what this does is it analyzes the trend of the temperatures and finds a point which is anomalous, one that doesn't really fit well with the others. So let's see what happens when I hit enter. It's analyzing the data, and it went through a whole bunch of these. So you see the year and the time and the temperature. And so false means this is not an anomaly. So anything that's 800, 900, it's fine. But at 1,000, immediately it says it's true. It found an anomaly and it's highlighted in red. So of the entire string of data values, that one was the anomaly. And of course, you don't always have to consume it using the command line prompt. There are graphical ways to do this, but right now, for the purpose of the demo, we're just doing it in this fashion. So that won't be the last you'll be seeing of the Azure portal. There'll be plenty more AI and machine learning demos coming up in the upcoming modules. So that's it for this demo. Using cognitive services to deploy an anomaly detector is as simple as that. And that brings us to a nice conclusion to wrap up Module 1. In this module, we looked at what is artificial intelligence and what are some of the common artificial intelligence workloads. I also talked about the principles of responsible AI, and we got a tour of the Azure portal. And finally, we wrapped up with a demo of the anomaly detector. We have a lot of interesting content coming up in the later modules. But before we jump into that, let's take a 10-minute break to walk away from our computers for a bit and allow what I've shared to sink in. Come back refreshed and ready for Module 2. I'll see you then.